Hello, good morning, everybody. This is going to be a course on cryogenic engineering, and this is suitable for MTech students who are studying industrial refrigeration and cryogenic engineering. Okay, let me make the screen full screen. I hope it will become full screen now. Yeah, okay. Now, let me tell you what are the things we are going to deal with in this particular course. The objective of the course is to introduce the subject of cryogenic engineering to the students, to provide them the basics required from thermodynamics, heat transfer, and as well as refrigeration, to make the students understand the various methods to create cryogenic temperatures and to maintain it. This is going to be practical part, but we may not be able to do it here. But what we will be doing will be to provide the information of the various methods to create the cryogenic temperatures. The students should become aware at the end of the course of the wide technological applications of cryogenics in the various fields. And also, they should be able to recognize the engineering problems and they can be solved, which can be solved by applying cryogenic techniques. So the syllabus of the course will be to define cryogenics and its history, gas liquefaction refrigeration system, cryogenic refrigeration system down to millikelvin range, then important aspects such as superfluidity of helium, then properties of solids at cryogenic temperature, superconductivity, and then cryogenic insulations, storage and transfer of cryogenic liquids, cryostats, introduction to particularly the vacuum technology, and then cool down of cryogenic transfer lines, measurement of cryogenic temperatures, liquid levels, flow rates, quality, and so on. And we'll also deal with the cryogenic applications, cryocooler and its application, then principle of air separation, production of various gases such as oxygen, nitrogen, argon, and so on. The outcome of expected out of this course is to synthesize and apply the basic concepts of cryogenic engineering, describe various applications of cryogenic engineering and technology, acquire the knowledge in various cryogenic liquefaction refrigeration system, identify the avenues of the subjects to help the student to choose a specific area of interest. Well, there are some reference books, particularly Hasselton, G.J., Cryogenic Fundamentals, then C.A. Bailey, Advanced Cryogenics, and then the Randall F. Barron, which is Cryogenic System. It's one of the very good books, and you can say it is a standard textbook for cryogenic engineering. Well, the course will be equivalent to a 3-credit course, and it consists of 5 modules, and the modules are listed out here. And let me read through the modules so that you'll get an idea. The contact hours may not be exactly matching. I will leave out the contact hours. Okay. Other than that, we can just go through the modules. In the first module, we will study the definition history of cryogenics, gas liquefaction and refrigeration systems, thermodynamics of gas liquefaction, liquefaction cycles, cryogenic refrigeration system down to millikelvin range, dilution refrigerator, and adiabatic demonization. Then in module 2, we will talk about the properties of cryogenic liquids, superfluidity, properties of solids at cryogenic temperatures, mechanical, thermal, electrical, magnetic properties, superconductivity. In module 3, we will deal with the cryogenic insulations, storage and transfer of cryogenic liquids, cryostats design, introduction to vacuum technology, cool down of cryogenic transfer line, process phenomena, etc. In module 4, we'll talk about the instrumentation in cryogenics, measurement of temperature, thermocouples, platinum resistance thermometers, semiconductor thermometers, liquid level measurements, flow rate measurements, and quality measurements, etc. Now, in the last module, module 5, cryogenics and the application will be dealt with in various fields. In engineering, space technology, cryogenic fuel rockets, then space simulation, chambers, cryogenic heat pipes, nuclear research, bubble chambers, spectroscopy, cryopumping, food processing, biology, medicine, and LNG technology. Cryocooler is another important area, and its applications will also be dealt with in the module 5. Principle of air separation, production of gases like oxygen, nitrogen, and argon will be dealt. Well, at the end of the course, this is a basic course, we expect the student to learn something about cryogenics and its fundamentals and its applications. These are the things what we expect to learn. Okay.